So we are dealing with the fourth problem in this series, and it is problem number 1.28. So the fourth problem in this series is asking us, and it is also problem number 1.28. So the problem is stating a small body is thrown at an angle to the horizontal with the initial velocity v0. Neglecting the air drag, find the displacement of the body as a function of time. The mean velocity vector averaged over the first t seconds and over the total time of motion. So the first thing that we need to understand about the problem is that everything in the problem is being discussed in vector notation. So we will try to answer in vector notation. So the initial velocity vector so we can write it as v0 vector, and then it is having an acceleration of g vector. So if we write position as a function of time, so position of the particle as a function of time, so it can be written as initial velocity vector t half acceleration vector g t square. So if we think in terms of the displacement of the body as a function of time, then this is the answer to the first part which we have. Now the second part is asking us the mean velocity vector averaged over the first t seconds and over the total time of motion. So the average speed in the first t second, so this can be written as position vector as a function of time t minus position vector at the starting of motion divided by total time t. So if we substitute the values here, we get v0 plus half gt. So over here we can say that the average velocity v average can be written as v0 plus half gt. So this is the answer to the second problem which is asked in the problem. Now for the third part, the problem is asking us to calculate the mean or the velocity vector over the first t seconds and over the total time of motion. So this is for the first t seconds, and now we want to discuss for the total duration of motion. So for the total duration of motion, so to understand this, we are saying that when the particle is projected, it is having a velocity v0 at a certain angle which we don't know, not mentioned in the problem. The g vector is in this direction. So if we are designating v0 as a vector and g as b vector, and if this angle is theta, which is angle of projection, then this angle is 90 degree in the vertically downward direction. So if we use dot product, so in terms of dot product we can write v0 dot g equals magnitude of v0 magnitude of g cos of 90 minus theta, cos of 90 plus theta, which is the angle between v0 and g vector. So cos of 90 plus theta can be written as minus sine theta, and minus sine theta can be written as v0 dot g divided by magnitude of v divided by magnitude of g. Now the total time of flight t is written as 2u sine theta by g, which is the working formula. So if we substitute here, we have 2 v0 by g and then sine theta. So sine theta can be written as minus v0 dot g v0 dot g by magnitude of v naught magnitude of g, so this becomes g square. So if we substitute this in the expression that we have obtained for v average over here, this one, so the magnitude of v average over the entire duration of motion can be written as v naught plus half g, and then we have minus v naught by g square, v naught dot g by magnitude of v, and hence the final answer looks like v naught, 2 and 2 cancel, 1 g cancelled out, so we are having v naught minus v naught dot g by magnitude of v cancelled out, we have g square dot g. So this is the expression for the magnitude of v vector over the entire duration of motion. So for the entire duration of motion, we have the answer as v naught minus magnitude v dot g by g square dot g. So this is the answer for the problem which we have discussed, problem number 1.28.